For training our model, we are going to use a synthetic dataset that I have generated, and the file is also present. I'm not going to code it. You can get it from the GitHub of this code repository. So it has 12 columns, and it takes the smartphone features, and it returns what is the probability that this exact specification will get returned. So for example, if given brand condition, is it open box, new, refurbished, RAM, storage, carrier, discount, rating, or number of days since it was first purchased. Based on that, we tell whether it is the probability of it getting returned or not. So this data set has about 5,000 data points, very small data set, and it has about 17% data which has a high return rate. So let's quickly learn how can we write code with MLflow. So first thing first, we're going to install the dependency, which is uv add MLflow, and we also need the scikit-learn because we are going to use the simple random forest. And let's also install pandas and numpy, matplotlib to visualize the performance of the model, seaborn, let's install it as well, plotly, Jupyter, IP kernel. Kernel. Let's give them a bit. It's installing all the required dependencies. Meanwhile, let's create the model. I have created a separate folder for the first episode. Let's make it train baseline because this is going to be our first model, and let's wait for it to get installed. And there we go, our model has been installed. Let's spin up the MLflow UI, UI. So this will start the MLflow UI, and this is how your MLflow UI will look like. There's no experiment right now, no model. This is clean slate. First time we are adding the MLflow. Now let's import the dependencies. Let's import matplotlib .pyplot as plt from sklearn .compose import column transformer from sklearn .ensemble. Let's import random forest classifier, and from sklearn matrices, import accuracy score, F1 score, ROC AUC score, confusion matrix. From sklearn dot model selection, import train test split. From sklearn dot pipeline, import, let's import pipeline. From sklearn dot preprocessing, import one hot encoder, standard scaler, and from MLflow dot models, import infer signature. So now let's define the directories from let's also import MLflow. And we also need OS, import pathlib. From path, import path, and let's also import MLflow.sklearn, and we have to import numpy as numpy, import pandas as pd, and I think we are good. Let's define the paths. Let's define the root of this project as path dunder file. Let's make it parent. This is going to be really helpful because I believe you guys are running this code on Windows, Linux, anywhere it is going to work. So what I am doing is I am telling it from root in that same folder you're going to find the smartphone SMART PHONE .csv, and now let's define artifacts. Let's also save them in the artifact folder. Because the ML processes will generate some artifacts, and let's also make right away once this code execute, let's make the directory and exist is equals to true. If this directory already exists, then we are going to skip it. Now let's do the MLflow setup. So let's do one thing. Let's MLflow set experiment. Let's make it as model baseline, or let's do, since we are going to refer multiple episode, So let's make it episode 1 baseline. It is going to helpful in because we are going to use the same model in the coming up series. So let's load the data. So df is equals to pt.read_csv, and we can pass data, and then we can split. df.drop, let's drop the last column. Return, and the label is df returned as type integer. These are our features, this is our target. Now let's bring the numerical column separately. Select t types, include numpy dot number dot columns to list. So this way we will be automatically getting all of the numerical column name. And then let's get the categorical columns. Select t types, exclude. Again, if we exclude the numpy dot numbers, then this way we'll only get back the columns to list. So now it is going to help us in identifying the numerical and categorical column. You don't have to hard code anything. We'll try as much as possible to prevent hard coding. Let's do preprocessing. Preprocess column transformer. Now let's transform. Let's build first the numerical transformer. Numerical. Let's do standard scalar, and we can do with mean is false, and let's pass all the numerical columns. So next transformation we'll do for categorical they will be of one hot encoded, and we can say handle unknown as ignore, because since I have prepared this dataset and I have made sure that there is no unknown value, and we can pass the categorical column in this. Let's try to run see if any error that comes up. Episode 1 train baseline. Hopefully it will work. So meanwhile, let's build our model. Alright, there is an error. Smartphone returns. Maybe I have written a wrong name. So let's do it again. Yeah, so there's no error. We can continue building the model. So let's model an hyperparameter. So let's define the number of estimators. So let's do integer os dot get, or we can, usually these things are passed as a environment variable, but for now let's make it 200 max depth. Or let's do one thing. I'll do the code that goes in the production. So os.get env rf and estimators, and if it is able to find it, otherwise we'll give a default value of 200. So that's how, because we want to make it configurable, that's the idea. Integer os, there are other ways as well, like you can pass it as the argument get env random forest max depth. Let's take it 12 if it is not provided, and let's give random state. Now let's define the model as random forest classifier. Number of estimator is number of estimators. Max depth is going to be max depth. Random state is going to be random state, and let's give number of jobs as, let's take it -1, and we can define the class waste as balanced. Now let's define the classifier as pipeline. Its steps are, first the preprocessing. We'll use the preprocess that we have defined here. Yeah, and after that it goes into the RF random forest. Let's pass our model. So this is an array. Perfect. Now let's call our train test split. So previously we have splitted the features and target variable. Now we are splitting the data. X train by X test. Train test split X comma Y. Let's give the test size as 0.2 and random state as random state, and stratify Y. We want to do the stratified sampling. Now this is the traditional machine learning writing way. Apart from that, we just had done an MLflow experiment setup. Now we are going to use with context for MLflow dot start run, and let's give the run name as baseline random forest, and inside that we are going to logs the MLflow parameters. And MLflow dot log param and estimator is an estimator, and max depth. So that way we will have the track, like for that this experiment, these are the hyperparameter that were used. So now let's run our classifier fit X train and Y train, and then after that we'll do the eval. So let's get the predicted PRED CLF dot predict Y test, sorry, X text, and let's also get the probability. As for now it's none. Let's do try and catch. So Y probability CLF predict probability X test everything except exception. For now let's pass it. So now we'll have the probability, and that will be helpful in calculating the ROC AUC. So now let's get the accuracy score. Let's give Y test and Y predicted, and let's calculate the F1 score. y test, y predicted. So MLflow dot log metrics. This is a metric. Earlier we logged the parameter. Accuracy is and MLflow dot log matrix f1 is float of 1. Now if y probability is not none, then we can calculate the AUC, ROC, AUC score, y test, comma, y probability. MLflow log metric C float UC. Now let's draw the ROC curve. So let's import from sklearn dot matrices, import ROC curve display, precision recall display, and we can as plt dot subplot fig we can define the figure size as 5,4, and let's get the figure and access. Figure ROC, figure access ROC. And then ROC curve display from predictions, y test, y probability, and access is access ROC. So we can give path. We can give the path as artifact. After that, it will take ROC curve dot png. Now figure ROC dot tight layout. Dot save fig ROC path, and let's give the DPI of 160, and then we can plt.close the figure, ROC, and we can log the artifact, the MLflow log artifact as str of ROC path. And that's how you save the model performance. Now let's do one more thing, and let's save like artifacts. Let's give the information of class balance. Y dot value count, normalize true, rename access to class, reset its index, and let's give the name as PCT. Class balance path is artifacts / class .csv to CSV class balance path index, let's make it false. Now MLflow log artifact, we can give the name str of class balance path. And one more thing is the confusion matrix. Confusion matrix we can calculate as CM as confusion matrix, and we can pass y test comma y predicted values. plt.subplot let's give the dimension of 4 cross 4, then axcm im show and then we can put cm cmap, let's give it blues, set x label predicted values axcm dot we can give y label as actual, and now we can enumerate for I comma j comma v in np dot nd enumeration cm, so axcm dot text give the HA as center. These are the just formatting, and VA also as center. And we'll also need to give the color bar so that it's visible and then cm path we can define artifacts / png figure cm same thing, figure cm dot save fig. Then we can close the plot. Once that is done, we can log the artifact and str dot cm path. Finally, let's log the model. So let's infer the signature. Extreme dot head. Let's log 5 examples of input. infer signature will pass the input examples clf.predict examples flow.sklearn.log model clf name, let's give it model, signature is signature, and then input example. Let's also add a print statement. Accuracy is this, and F1 is, hopefully this is going to run. So there is error at subplot. Alright, let me define this way. Fig hopefully this is the last error. So clf name signature it's log model, not load. Let's see. Yeah, so model is trained, accuracy is 0.81, and this is the F1 score. Let's see our MLflow UI. Look, this is the experiment that got saved, some failed runs, and the final one, which is the success run. It is giving the information and all artifacts. See, all of them are getting saved here. That's the nice thing about MLflow. And this episode was more on the MLflow artifacts, and in the next video we are going to learn about how we can do a train sweep in the MLflow. You can see all of the matrices that are logged here, and yeah, that's pretty much for the first video. I hope that you were able to learn the basics. Thank you.